Hi everyone, I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the application of mathematics elastic deformation. Stretching of an elastic membrane. An elastic membrane in the x1 x2 plane with boundary circle x1 square plus x2 square equal to 1 is stretched. So there is a point P of x1 comma x2 goes over into the point Q of y1 comma y2 is given by y equal to y1 y2 which is equal to ax, where ax equal to the matrix 5 minus 3 3 5 into x1 x2. In components, y1 equal to 5x1 plus 3x2, y2 equal to 3x1 plus 5x2. Then find the principal direction, that is the direction of the positive vector, for which the direction vector of the position vector y of q are exactly opposite. What does the boundary circle take under the deformation? So here we want to calculate the principal direction, and also you want to calculate the boundary circle under the deformation. So for the solution part, we move on to the take the given matrix A equal to 5 3 3 5. The characteristic, it is a 2 cross 2 matrix. The characteristic equation is for the 2 cross 2 matrix is lambda square minus d1 lambda plus d2 equal to 0. But d1 is the sum of the diagonals, that is 5 plus 5 equal to 10, and the d2 is the product of the matrix, that is first cross minus second cross. So the first cross value minus second cross value, got the answer as 16. So this way, if we know these two values, we can substitute here. So the equation is lambda square minus 10 lambda minus 6 16 equal to 0. From this, 2 and 8 are the eigenvalues of this matrix. So next we move on to the eigenvector. The eigenvector is nothing a minus lambda I into x equal to 0. So the conclusion of this equation is just writing in diagonal with minus lambda. So 5 minus lambda 3 and 3 minus 3 5 minus lambda into x1 x2, which is equal to 0 matrix. So here we can choose the case 1 for lambda equal to 2 in 1. So if 5 minus 2 is 3, 5 minus 2 is 3, as well as the diagonal values are same. Here also the same values we got. So equal value, single equation at last we got. So in this equation we can calculate these two values. So take this 3x1 keep left hand side, and then minus 3x2 is take it to the right side. So minus 3 and 3 you can cancel, and left hand side x1, right side minus x2 got at last. So by assumption cross multiplication method, so x1 divided by, take this minus the coefficient minus 1 to the denominator, and x2 divided by the denominator 1. So from this, x1 is equal to minus 1 and x2 equal to 1. We got the first eigenvector. Next we move on to the second eigen lambda value, lambda equal to 8. So when you substituting 5 minus lambda, that is the 5 minus 8 is minus 3 minus 3. So we are getting the same equation. So same equation means again we follow the same rule. Same rule means here we are getting x1 is equal to x2. So by that same procedure, at last we got x2 equal to 1 1. So if we know these two eigenvalues, we can move on to the next step. So the next step is to calculating the theta value. So how to calculate the theta value is nothing, it is just follow the above formula. The formula is Before going to this, the formula, you want to follow the formulas. Just